Good morning, everyone, and thank you so much for joining us. Today, we're going to be talking about geometry symbols. The reason that these are important is that there are certain symbols that you are going to see when interacting with different two-dimensional and three-dimensional figures in geometry, as well as lines, that if you don't understand what they mean, you're not going to be able to understand the dimensions, the descriptors, and what is going on with those figures. Some of these are probably going to be a bit of review for you. Others are maybe new to you, but that's okay. That's why we're here. All right, so for our first symbol, we're going to be talking about the symbol for a line. So for a line, you have a line with arrows on each end, meaning that this line is continuing on into infinity in either direction. Now, when you're looking at an example like line AB here, you see that there is points A and points B, but then these lines still continue into eternity. And this is shorthanded by saying that AB is a line with the symbol for a line above the AB. Let me get this to flatten out a bit for you. All right, our next symbol is talking about rays. Now, with rays in geometry, it is going to be represented by a specific point where the ray begins, and then a line with an arrow at the end that shows that it is continuing into infinity in one direction. So, for example, you have line AB, or ray, I apologize, ray AB, because the ray begins at point A and continues in the direction of B into infinity. And it is shorthanded by uppercase A, uppercase B, with the ray symbol above it small. For our next one, we're going to be looking at a line segment. Now, a line segment has a line, but it has a definitive starting point and ending point. It does not continue into infinity forever. It is only this section of a line. So, for example, you have line segment AB. It starts at A, it ends at B, and it is shorthanded by writing capital A, capital B, with the symbol for a line segment above it. Next, we have parallel. Now, this is a symbol and this is a concept that you are going to need to understand very, very clearly. Parallel lines, and I always like to remember what the definition is because there are two L's in the word parallel. Parallel lines are lines that continue and never touch. So even if these were line segments, they are side by side, but they never touch. But if these are lines that continue into infinity, no matter where they go, either direction, they will never ever touch. They will be perfectly side by side. And that goes if the lines are going horizontally, diagonally, or vertically. It doesn't matter what direction they're going, as long as they are continuing side by side and they never, ever, ever, ever touch. So looking at this example with a two-dimensional figure, we have a rectangle, and this rectangle is rectangle ABCD, and we can shorthand this by saying line segment AB is parallel to line segment DC. Okay, these two, even if they continued into infinity, would never ever touch. And we can also verify that line segment AD and line segment BC would never ever touch. Even if they continued into infinity up or down, they are staying in the same pathway together. Our next piece is congruent. Congruent is another word for equal. Now, when you have things that are congruent, you need to match the number of slashes. So for instance, These two lines are congruent. They have one slash mark each. But these lines are not congruent to these. These have two slash marks. So these two are congruent because they have one slash mark. These are congruent because they have two slash marks, but they are not congruent to each other. And then you have this third set of lines that have three slash marks. That means that they are congruent to each other, but because there's three here, these only have two and these only have one. None of these lines outside of their matched pair are congruent. So looking at an example of a triangle, this simply means that the right side and the left side are congruent. They're equal length, but the bottom side is not. Then if you look at this rectangle, we know that the top and bottom lines on this rectangle are congruent because they have one slash mark each. They match. And then the left side and the right side have two slash marks. So they match, but they are not congruent to the top and bottom, just like the top and bottom are not congruent to these two. And now we have a trapezoid, a type of quadrilateral, which you'll learn more about here in a little bit if you don't remember them. And we know just by looking at it that the top and bottom are not congruent to each other. While the top and bottom are parallel to each other, they are not congruent. But the left side and right side are congruent. They are the same length because they have the slash mark going through them. So always remember, match the number of slash marks in a figure or a given diagram, and you will be able to find the congruent sections. Now, an angle. An angle is always defined like this. You'll have the lines, and then this little circle piece shows you what direction the angle opens. I'm actually going to add one example to this because I feel it's really important. I'm going to kind of cram it in here a bit. If you have an angle that looks like this, the angle can go this direction. This just means that this angle is opening up this direction. Okay? So you always know what direction the angle is opening based on where this little partial circle is. Okay? Now, for angle ACB, it is shorthanded with the little angle symbol and ACB. And then DEF, angle DEF. And we know that the angle is opening this direction because of where our little semicircle is. And last but not least, we have right angles. And we're actually going to talk more about right angles in the next, excuse me, the next video as well. Right angles create an L, a perfect L. Now, if you're ever unsure if an angle is a right angle, use the corner of a piece of paper. A piece of paper has a perfect right angle. All you have to do is line up the paper in the corner of the angle, and if you see that perfect L, then it is a right angle. It doesn't matter what direction it faces. Okay? That's still a right angle. Right? And a right angle is notated by this little square in the corner. So that you will, that's what they actually call it. They say that a right angle is a square angle because they put that little square in there. And you can also see this here in this figure. We have lines AEC and DEB that create a perfect cross, a perfect X. You have a right angle AEB, right angle BEC, right angle CED, and right angle DEA. All of those create a right angle. no matter which direction you're looking at it in. All right. So these are the main components of geometric symbols that you will need to make sure that you are aware of. If you have questions, if you need support, please let me know. We'll see you next time, guys.